Dear children, in this video, I would like to discuss some problems from your NCERT textbook, vector chapter. Okay, so let me take the first exercise, that is 10.1. So the first question, you have to take the textbook and note down the question. The first question is represent graphically a displacement of 40 kilometer 30-degree east of north. 30-degree east of north. This is the question. Represent graphically a displacement of 40 kilometer 30-degree east of north. So how to represent? So first we have to draw two perpendicular lines to indicate the directions, just like x, y, z axis, x, y axis. So suppose the intersection is taken as O. So this is the direction E, east, west, north and south. So our question is 40 kilometer 30-degree east of north. That means from north we have to turn 30-degree towards east, and the displacement is 40 kilometer. So we have to draw from the point O, making an angle of 30-degree to the north direction. Okay, to draw a line segment like this. That end point can be taken as A, mark it as A. Okay, so the angle rotated towards east is how much? That is 30-degree. So this OA, the vector directed from OA, will be the required displacement vector. Okay. Now the second, third questions are just to classify whether scalars or vectors. I think there is no difficulty, we can do. The fourth question is again very simple question. There is a square figure is given there and some vectors are marked. This side is A vector and this is B vector and this is C vector and this is D vector. This is the figure. You can see the textbook. So the question, first one is, what are the co-initial vectors? Co-initial vectors. From the diagram, we can see vectors having the same initial point are called co-initial vectors. So what are those vectors in the figure? The vectors are A and D. So A and D will be the co-initial vectors. Next question is equal vectors. What are the equal vectors? So very clearly in the diagram, you can see that the vector B and the vector D are equal. Both are having same magnitude and the same direction. For second part, the answer is vector D and vector B. And third question is collinear but not equal. Vectors are collinear but not equal. So collinear होने के लिए chance तो B and D है, A and C है ना? But D and B are equal. So only option remaining is A and C. A and C, you see, both are having opposite directions. A and C having same magnitude but opposite directions. But anyway, they are parallel. Therefore, they are collinear vectors. So the third part, the answer is vector A and vector C. I think the first exercise only this much is enough. The remaining are very simple problems you can complete by yourself. Then we will discuss some problems from the second exercise. That is based on the addition, subtraction, scalar multiplication, section formula. Unity vectors, okay, collinear vectors, etc. Second exercise, you note down problems for the textbook. The first question, compute the magnitude of the following vectors. Exercise 10.2 I am discussing. The first question, compute the magnitude of the following vectors. Some vectors are given. The first one is A vector is equal to I cap plus j cap plus k cap. What is the modulus of this vector? What is the magnitude of this vector? So what is the magnitude of this vector? Nothing but root of 1 square plus 1 square plus 1 square. That is nothing but root 3. Clear? Second question, write two different vectors having same magnitude. Write two different vectors having same magnitude. There are so many examples. Different vectors having same magnitude means I can write very simply I cap and j cap, j cap and k cap. Okay, different vectors having same magnitude. So I can write I plus 2j and 2I plus j. Like that you can write so many examples. Different vectors must be different vectors but same magnitude. Next question, write two different vectors having same direction. Write two different vectors having same direction. Vectors must be different but same direction. So I can write I and 2I, I cap and 2I cap having the same direction. Okay, I is vector along the x-axis, positive x-axis. 2I is also a vector along the positive direction x-axis, positive x-axis, but both are having different magnitudes. You can write any example. You write any vector, then multiply by a scalar. That is the idea. Any vector, then multiply by a real number. Then you will get vectors in the same direction. Okay, multiply by a positive number, then only you will be getting the same direction. If you multiply by a different negative number, then the direction will be opposite, reversed. Okay, then I think all these problems are very very simple problems. Write a unit vector. Seventh question, write a unit vector in the direction of the vector. A vector A is given I plus 2j plus I plus j plus 2k. That's the question. Okay? Question can be anything, no problem. I plus j plus 2k. If the number have changed also, you will get a different answer. That's all. Okay, anyway, this is the question in the textbook. What is the modulus of this vector? First write the modulus. The modulus of this vector is root of 1 square plus root of 1 square again plus root of 2 square. That is 1 plus 1, 2 plus 4 equal to 6, root of 6. To get the unit vector along any vector, what we have to do? Find the modulus and divide by the modulus. Any vector divided by its modulus will be the unit vector, that is a cap by notation. So a cap is always equal to a vector A divided by its modulus. That means I plus j plus 2k all divided by root 6. So this is the required unit vector along the given vector A. Okay. So my dear children, all these problems are also very very simple problem. If you understand all the concepts, then we can very easily do. Then ninth question. Question number 9. Two vectors are given, A and B. The vector A is equal to 2I minus j plus 2k, and B vector is equal to minus I plus j minus k. The question is find the unit vector in the direction of the vector A plus B. Okay, find a unit vector in the direction of A plus B. So first to find A plus B. What is A plus B? 2I plus minus I means I, minus j plus j means 0, 0j, 2k minus k means k. So this is our A plus b. Okay, then we have to find the modulus. Any vector divided by the modulus will give the unit vector in that direction. So modulus of this f plus b vector is root of 1 square plus 0 square plus minus 1 square. That is equal to root of 2. So now divide by the modulus a plus b divided by mod a plus b. Okay, the unit vector along the vector a plus b. Okay, we can write the notation also. Let us say a plus b cap, and that's equal to a plus b. A plus b is the vector I minus k divided by the modulus is root 2. So this is the required unit vector. Then question number 10. Write a vector in the direction of the vector 5i minus j plus 2k, which has magnitude 8 units. Okay, which has magnitude 8 units. Means we have given a vector. Remember. Now we have to write another vector in the same direction having magnitude 8 units. That's the question. So what we do? We first find a unit vector in the same direction. Then if you multiply by 8, we will get a vector of magnitude 8 in that direction. Okay. If you multiply the unit vector, then we will get a vector in that direction. If you multiply by 8, you will get a vector of magnitude 8. If you multiply by 10, you will get a vector of magnitude 10 units. So the idea is first to find the unit vector, then multiply by 8. I think you can do by yourself. Find the modulus of this vector, divide by the modulus, then multiply by 8. Okay, the remaining we will discuss in the